Hello everyone, here's a question from Power Play. This is second figure it out and this is based on new syllabus, and here we have 13th question. Calculate and write the answer in scientific notation. So we use scientific notation whenever the numbers are very big, huge, so we shorten it by using a scientific notation so that the writing will be easy and it is easy to read too. And here we have a 4 questions. So first we'll solve this and then we'll write them in a scientific notation. Let's look at the first one. If each person in the world had 30 pieces of clothing, find the total number of pieces of clothing. So here they're talking about each person in the world. This means we have to write down total population of this world. So total population, which I just searched in a Google, it found out that there are total 8.2 billion people in this world. So I'll write total population. So total POP. I'm just writing POP. This means population. Total population, let me write POPU. So understand that this is population is 8.2 billion. Now what is billion here? Billion means 100 crore. And in 1 crore, it is 1 followed by 7 zeros. Okay, 1 crore. And here we have 100 crore, which means, okay, let me write this. So 1 crore is 10 to the power 7. So you have 1 followed by 7 zeros. And here we have 100 crore. 100 crore means 1 billion. So this will be, so 100 crore will be 100 times 10 to the power 7. Okay, so what is 100? It is 10 square. And here 10 to the power 7. Bases are same, so the powers will get added up. 2 plus 7 is 9, so we get 10 to the power 9. So this is 1 billion. Okay, so 100 crore means 1 billion, so 1 billion means 10 to the power 9. There will be 9 zeros, so 1 followed by 9 zeros. So this is equals to 8.2 times 10 to the power 9. Now here they are saying if each person in the world had 30 pieces, so there are 8.2 times 10 to the power 9 people and each of them had 30 pieces. So total how many will be there? This means we have to multiply 30 by total population. So let's find out that. So total number of pieces of clothing. Sorry for handwriting, it's difficult to write with the mouse. So this is equals to each person have 30 pieces. This means 30 times there are total 8.2 billion people. 8.2 billion we can write as 8.2 times 10 to the power 9. Now here we have to multiply these two numbers. So what we can do here is we can avoid the decimal point, we can write it. So what I'll do, the easy method is, you have learned this in your lower classes, we can convert the decimal number into a fraction by just removing the decimal point. And here in 8.2 there is only one digit after decimal point, right? So how can I write this? I can write this as 30 times 82 by 10. So I'll get 10 in the denominator. This is how you convert. This is easy way to convert decimal number to a fraction. You have to just count how many digits are there after decimal point, and in the denominator you will write 1 and that many zeros. If there are 2 digits at a decimal point, you will write 100, 1 along with 2 zeros, times 10 to the power 9. So what I will do here, I will cancel this 0 and this 0. This you have learnt in your lower classes how to cancel the numbers. So you can cancel this in 10 table, or you can just cancel the zeros. Both are same. So what I get here, let me solve it here. So this is equals to 3 times 82 times 10 to the power 9. Now here we have 3 and 82. When you multiply these two numbers, we get 246 times 10 to the power 9. Now the question here is to write it in a scientific notation. In scientific notation, after the first digit, you will have a decimal point. That means after 2, I should have decimal point, but here I don't have decimal point, so I have to put decimal point. Now I cannot go and put decimal point like that. So what I'll do, now this you have to understand carefully. I want decimal point here, right? So again I'm going to use the concept of decimal in fraction. If I place decimal point here, how many digits are there after decimal point? There are 2 digits. This means I will multiply the numerator and denominator by 100. So you cannot just divide, you have to multiply too, you have to balance it, right? So you cannot just divide by 100, it will change the value of this whole number. So what we'll do, we will multiply, so that is 246 times 100, and here I'll divide it by 100, and here we have 10 to the power 9. I have to erase this part, I'm just erasing this portion. So this is equals to, now this is a fractional part. This fraction we can convert it to a decimal. You have learned this in your decimal chapter. If we have 100, then we have to move decimal point 2 places to the left. So here we have 246. This is a whole number, there is no decimal point here. So we'll paste decimal point here, and now we'll shift 2 places to the left. 1, 2. We get decimal point here. Times this 100, I write it as 10 square times 10 to the power 9. Now here we have a 10 and 10, the bases are same, so we'll add the power. So I get 2.46 times 10 to the power 2 plus 9 is 11. So I'll get 11. So this is one way of doing it, where I have divided this numbers by divided and multiplied by 100. Now this is one way of doing it. Now if you think this is too lengthy and long, I'm going to show you the easy trick to do it. What you can do is, we have 2.46, sorry, not 2.46, we have 246 times 10 to the power 9. Now I want to make it to the scientific notation, I want to write it down. So here I want decimal point here, right? And how many digits are there if I place decimal point here? 2 digits. So you just add 2 here. In the power, you have to just add 2. So 9 plus 2 is 11. So 2.46 times 10 to the power 11. You get the same concept. So I have introduced decimal point here. This means I am multiplying it by 100. And so this whole procedure, I have just shortened it. Instead of doing all this thing, from here I write directly wrote here. I place decimal point and I just counted how many digits are there, and then add that number here along with the power. 9 plus 2 is 11. That's it. This is a short way of doing it. So whichever method is easy, go for it. So this is short way. The detailed way I've explained here. So this is about the first question. So there are 2.46 times 10 to the power 11 pieces of clothing. This is our first question. Let's move on to the second one. Now in the second one, what they are asking, there are about 100 million bee colonies in the world. Find the number of honeybees if each colony has about 50,000 bees. So first we'll write down number of bees colony. So this is second question, number of bee colonies. This is bee colonies is, it's given as 100 million. Now million means 10 lakhs. In 1 lakh, we know there are 5 zeros, which is 10 to the power 5. Now 10 lakh means 10 times 10 to the power 5. Now here the power of 10 is 1. Bases are same, so add the powers. So 10 to the power 1 plus 5, which is 6. We get 10 to the power 6. So 100 million will be 100 times 10 to the power 6. So 10 lakhs means 1 million. Remember that. And here we have 100 million. So 100 times 10 to the power 6. How can we write 100? It is 10 square times 10 to the power 6. Bases are same, so we'll add the power. So 10 to the power 2 plus 6, it is 8. We get 10 to the power 8. So we have just solved one part of this. The second is, they are saying if each colony has 50,000 bees, how many bees are there? That is the question. So total bees will be, I'll write it here. So total honeybees, or just write a bees, total bees will be number of bees colony. How many bees colonies are there? 10 to the power 8. And number of honeybees in one colony. So this is 10 to the power is number of bees colony, and in each colony there are 50,000 bees. So to find out total number of honeybees, we have to multiply 50,000 bees by total number of colonies. How many colonies are there? 10 to the power 8. This 10 to the power 8 is the total number of colonies in the whole world. So to find the total bees, multiply this two. So 10 to the power 8 times, how many bees are there in each colony? 50,000. So 50,000. Now how can we write 50,000? This is 10 to the power 8. How many zeros are there? 4 zeros. So this is 5 times 10 to the power 4. Here we have 10 and 10 has a base, so we can add the powers. So we can write it as 5 times 10 to the power 8 plus 4. 8 plus 4 is 12. We get 5 times 10 to the power 12. Now whenever you have only one single digit, like here we have 5, we don't have any other number apart from that. In that case, this will be a scientific notation. You don't have to do anything. If we have 51 or 500 and some number like 516, in that case we have to put decimal point after the first number. Now since here I have only 5, and yes, the power should be always 10 to the power something. The base should always be at 10. So this is the answer. We don't have to convert this into decimals. So 5 times 10 to the power 12 is the scientific notation here. Done. Let's go to the third question. The third question is, the human body has about 38 trillion bacterial cells. Find the bacterial population residing in all humans in the world. So again, it's the whole world. So let me erase this part. This is third question. So trillion, they're saying trillion. Trillion will have 12 zeros. So 38 trillion means 38 times 10 to the power 12. Right? So number of bacterial cell, how many are there in one person, one human body? It's 38 trillion. Trillion means, remember, 12 zeros will be there. 1 followed by 12 zeros. So we can write this as 38 times 10 to the power 12. Now here we have to find the total population, right? Total population is, we have used the same thing in the first question. It is 8.2 billion people are there. So what we can do here is, we can multiply 38 and 8.2, so 8.2 billion. So let me just rewrite this. So bacterial population in the whole world, it is a total 8.2 billion people are there. So bacterial population in all humans will be I have used this in the first question, so I'm not writing it again. There are 8.2 billion people. Now billion means 10 to the power 9. There will be 9 zeros. I have showed this in the first question, so I'm directly writing it here. So it is 8.2 times 10 to the power 9. This is the total human population. And so if this many people are there, 8.2 times 10 to the power 9 people are there, and in each human body there is 38 times 10 to the power 12 cells are there. To find how many bacterial cells are there, we have to multiply the total number of people, which is 8.2 times 10 to the power 9, by how many bacterial cells are there in each body, which is this. So we have to multiply these numbers and get the answer. So we multiply 38 and 8.2, we'll see what number we get. So you can pause the video, multiply and get the answer. I'm going to write the answer directly here. It is the video is very lengthy, so I'm not multiplying here. So 8.2, when you multiply it with 38, you will get 311.6 times. Now write this exponents, the powers, 10 to the power 9 times, and here we have 10 to the power 12. So this is equals to 311.6. So let me first solve this side, that is right side. Here the bases are same, so we'll add the power. We get 10 to the power 9 plus 12. 9 plus 12 is 21. We get, I'm solving here, so we get 311.6 times 10 to the power 21. Now I have to shift the decimal point. So this part is clear. We have 10 raised to the power something. But in scientific notation, the decimal point should be after the first digit, that is after 3. So here I have to move the decimal point 2 places. So this I'm using a short way, which I've explained you in the first question, the easy trick. So I'm moving 1, 2. I'm placing decimal point here. So how many places I have moved? 2 places. So you add 2 here along with 21. So this will be 3.116 times 10 to the power 21 plus 2. This is short way of doing it. Now if you want, if you don't want like this, what you can do is, I want decimal point here right after 3. So how many digits are there? How many digits are moving the decimal point here? 2. So you multiply and divide by 100. That is other way of doing it, which is like, which include 2 to 3 step extra, or else you can use this short method. So we get 3.116 times 10 to the power 23. So this is a scientific notation. So this many bacterial cells are there in the entire human population in this world. So this is a scientific notation. So remember, scientific notation means if you have a 2 to 3 digits in here, then decimal point should be after the first digit, and here when you write the power or exponent, it should, or the base should always be at 10. So 10 to the power something. We cannot have here 2 or 3. The base should always be a 10. Now let's solve the fourth question. Now this is last question. So I'll erase this whole thing. So last question is total time spent eating in a lifetime in seconds. Okay, now here we need two things: total time spent eating per day and average lifetime. So this is completely the data is not like we cannot depend on 1% data, so we just take the average. So we'll take for the healthy person. So if a healthy person eat, his how much time he's eating and what is his average lifetime. So we have to assume here. So let's assume that the lifetime is 90 years. This is my assumption. Just cross check with your teacher again. So lifetime, let's take 90 years, and let's take total time the person is taking to eat. This is the average time, again is 15 minutes. So time taken to complete the meal is 15 minutes per meal. This is per meal. And how many times a person will eat? 3 times. So total 3 meals a day. A person will eat 3 times a day, right? So total 3 times he is eating, he or she is eating. Okay, now we have to find the time spent eating in one day. So how much time he's spending in one day? In one day he'll eat 3 times. So time spent eating in one day will be 15 minutes, and he's eating 3 times, so we multiply it with 3. 15 times 3 is 45. We get 45 minutes. So on average, the person is spending 45 minutes to eat his meal. Now we have to convert this to seconds because the answer need to be found for the seconds. So we'll convert this. So I'll just continue here. It will be 45. I'm converting minutes to seconds. 1 minute is equals to 60 seconds. And here we have 45 minutes. So 45 times 60. When you multiply these two numbers, you get 2700 seconds. I'm not showing the multiplication here because the video is already lengthy. So this many seconds he's spending to complete, like to eat his meals per day. Now we have to find for the lifetime. So here we have taken the average lifetime is 90 years. So let's rewrite. I have to erase this part here. So time spent eating in lifetime, I'm sorry for the handwriting, is equals to time spent in 90 years. We have assumed that average lifetime is 90 years. So which is equals to, this means how much time he has taken to eat per 1 year times 90. So here, so let me rewrite this. Time we have to find for 1 year. Time spent eating in 1 year times, we have, since we are finding for 90 years, we multiply it by 90. So if we know how much time he is spending to eat his meal in 1 year, and using that we can find for 90 years. We have to just multiply that time by 90. In 1 year, how many days are there? There are 365 days. So this is equals to, I'm again writing it, time spent eating in 365 days. Now I'm writing this in a days because I know for 1 day, and using that I can find for 365 days. So this is equals to, I'm writing it here. So time spent eating 1 day, we know for 1 day it is 2700 seconds. We found for 1 day, right? We'll use that to find for 365 days, and using that we can find for 90 years. That's why we are getting a lot of multiplication here. 365 days times 90, and now I know for 1 day I'll multiply that with 1 day time. So 1 day times, in 1 year there are 365 days, therefore I multiplied by 365, and we are finding for 90 years, therefore I am multiplying it by 90. So I have a big number here to multiply. So this is equals to, I know for 1 day the person will take 2700 seconds, and this is for 1 day. If we have to find for 365 days, I have to multiply it by 365. Now this will give us total time taken for 1 year, and here I have to find for 90 years. To find that, I'll multiply it by 90. So instead of finding it in 3 different steps, I'm doing it in a 1 step. Now I have to multiply this and get the answer. So here you can multiply, the easy way is multiply 27 and 9. So let me solve it here. There is no space, I'm solving it here. So this is equals to, when you multiply 27 and 2790, you will get 243. So 27 times 9 is 243. Here I have a 20 and here I have 10. So total I'll get 3 zeros. So this is how I multiply. First multiply the whole numbers. 27 times 9 is 243. 2 zeros here, 1 0 here, so total 3 zeros. Times, we have 365. Now how can I write this? I want the base 10 to the power something, right? So I gonna split this. I can write as 243 times 1000 times 365. So here I have to multiply this three digits. Multiply 243 and 365, you get very big number. I know the number, I have multiplied already. It is 88,695 times 1000. So this 1000 I can write as 10 to the power 3. Now I have to write this in a scientific notation. In scientific notation, what you will do, you have to put decimal point after first digit, which means I have to place it here. So if I place it here, how many digits are there after decimal point? There are 1, 2, 3, 4. So that 4 you add it here in along with this 3. So this will be, so let me write it here. In the next step I'll do it. So I'll write 8.8695 times 10 to the power. You can write 3 plus 4 directly here, or you can write as 10 to the power 4 times 10 to the power 3. You can write it in that way too. So instead of multiplying and dividing it by 1000, now why 1000? Because there are 4 digits. 4 digit means you will get 1 along with 4 zeros, which is 10,000. I'm sorry, it's not 1000, it is 10,000. So instead of multiplying and divide by 10,000, I'm writing that 4 here in the exponent. So we get 8.8695 times 10 to the power 7. So this is the scientific notation. Now this is very lengthy video, I'm sorry for that, and here the units will be seconds. So a person will take this much seconds to eat his food. So this is 13th question. I hope it's clear. If you have further question on the scientific notation or any doubts on any other topic, you can drop a comment. Thank you so much for watching.